Let's look at this question. The figure shows 20 congruent circles arranged in a rectangle. Find the ratio of the length of the larger side to that of the smaller side of the rectangle. Okay. Let us try and do this. Let us try and do this by using the radii of the smaller circles. So we have 1, 2, 3, 4, 5, 6, 7. Because we have 7 circles here, we have 14 times the radius. So the longer side is 14r. That I know for a fact. Now also let's look at the centers of some of the circles. When you join this line and this line and this line and this line, first can you see an equilateral triangle get formed, 2r, 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 and then when you join the centers here, can you see, let me name these points A, B, C. In triangle ABC, if this is 2r, AC is 4r, AC is 4r, this is 60, this is 60, because this is 60, this will be 120, because this is 120, this will be 30, and this will also be 30. So effectively you have a 60, 30, 90 triangle. Opposite 30 you have 2r, so opposite 60 you will have 2 root 3r. Okay, so this length here is 2 root 3. This should be r and this should be r. So the length of the smaller side will be 2r plus 2 root 3 r. We were only supposed to find out the ratio of the larger side to the smaller side. So it will be 14r divided by 2r plus 2 root 3r. Okay, so this cancels, this cancels, this cancels. I will end up getting 7 by root 3 plus 1. Okay, if I end up getting 7 by root 3 plus 1, how do I turn this around? Okay, I will have to rationalize it. None of the options fit. So I will get 7 into root 3 minus 1. Whole thing divided root 3 plus 1, root 3 minus 1 by 2. Therefore, now this ratio is familiar. It will be option B, which will be the answer to this question.